Alright, now let's think about what happens with negative exponents. We saw a little bit of a brief preview of kind of what happens with negative exponents up above, and when I was talking about zero exponents. But let's think about how we would get that using the numbers or using these laws of exponents. So, using the basic ideas that I used at the beginning of this chapter, or this section rather, if I took x cubed over x to the 7th, there should be 7 there, 1, 2, 3, 4, 5, 6, 7, okay, and I did some cancellation. I would cancel an x with an x, an x with an x, and so on. I'd end up with nothing up top. Well, I really have the nothing of multiplication, which is a 1 up top, and I have x to the 4th down below. You'll notice I end up with 4 copies of the x on the bottom. And that 4 you could think of as 7 minus 3. But I know that this rule, this a to the r over a to the s equals a to the r minus s, this needs to be true no matter what else is going on. So even though this is true, this rule still needs to be true. And if I was to follow that rule exactly as it's stated here, this would be x to the, well, 3 minus 7, which is x to the negative 4. So what we see is that these two values are the same. X to the negative 4 is the same thing as 1 over x to the positive 4. In general, the rule of exponents that we're seeing here looks like this. If we have a to the opposite of r, this is the same thing as 1 over a to the r. So if we have a negative exponent that is in our numerator, so I'm saying this is in the numerator because I can always pretend it is over 1. What that means is that I can make it into a positive exponent by just moving it down into the denominator. Now, don't feel like this 1 is not moving around. You can just say that you can throw in 1s wherever you'd like. And that's why I was able to throw in a 1 there. So, something that some people make a mistake with here is, let's say we had 2a to the negative r. Well, that 2 is not affected by this opposite of r, so that would still be in place. We would get 2 times 1 over a to the r, which is 2 over a to the r. You can see the 2 is in the numerator here. It stays in the numerator there. Oops, that's supposed to be an r, not a 2. It's the thing that's raised to that exponent. That's the only part that moves around. We end up with 2 over a to the r here. So in this instance, we have x to the negative 4. This is the same as having the x to the positive 4, but in the denominator. I have to have a 1. I have to have something up in the numerator, so I just put a 1 up there because it's the only thing, well, it's really the only thing I can put up there. Alright, and let's look to see what happens when we have negatives both in in the base of the exponent, or in the base and in the exponent. Well, let's see. We know that since this is a negative exponent, then this means this is the same thing as this stuff in the bottom of the fraction raised to a positive exponent. So far so good. I've dealt with the fact that I had a negative exponent. But I still have parentheses in here, and in general, when you're trying to simplify, you want to get rid of parentheses. So let's figure out if there's anything else we can do. We have the opposite of x to the 4th power. Well, I'm taking the opposite of something, and I'm raising that to the 4th power. So I would essentially have 4 copies of that negative, and they would all end up canceling each other out. I would actually end up getting exactly 1 over x to the 4th. Now, when you look at this, you might think somehow that negative and that negative are canceling each other out, but that's not really what's going on here. It's the fact that that's a negative on the inside there, and there's a even number up there. It's a 4. That's the important part rather than it being a negative. Alright, let's look to see what happens if it's not in parentheses. If I have the opposite of x to the negative 4, this is the same thing as saying negative 1 times x to the negative 4. The opposite is, taking the opposite of something is the same as multiplying by negative 1. So I'm just doing that. So then I can see this x to the negative 4, that's going to drop down into the denominator to become x to the positive 4. And the negative 1 stays put, or I can put the negative out in front of the fraction if I'd like. I could say the opposite of 1 over x to the 4th like that.